Okay, it's 4 o'clock, so let's get started. Very beautiful afternoon to you all. I just want to go first through the announcement, and I'll address any queries as we progress through the session. Boy, first, welcome back. How was your break? You all can hear me, yes? Hello? Okay, cool. How was your break? Good? Yeah, it's not like much of a break, right? You keep doing work. All right. Your test is scheduled for tomorrow. Now, if you have not set for your short test 1 and you missed with a genuine reason or you provided supporting document that were accepted, then please understand that your MST will be 15%, not 10%. That's very critical. Also be mindful, there will be no supplementary MST papers, so make sure not to miss this exam. Is that clear? Now, the venue is your respective for face-to-face Lovala and online Lovala as well. This is our lecture room, 019-101. For regional students, please contact your personnel. They have already received an email on Monday along with your exam paper. Sorry, on Tuesday, not on Monday. Along with your exam paper, so you should be able to liaise with them in regards to your venue. Our learning outcomes, you will be explaining concepts, definitions, and processes of data mining, and apply various data mining methods to interpreting results as well. That means the focus is on both theory and calculations. Materials covered are everything from week 1 to week 7 inclusive. The focus are on the following topics. So you'll have questions in regards to data preprocessing. We'll examine that shortly. We'll look at what sort of classifiers we will be targeting. We will be looking at what exactly I want you to know about decision trees. And am I looking at 2-dimension or multi-dimensional confusion matrix? We'll look into that as well. You will be handling naive Bayesian classification, and of course, to calculate that or to calculate your nearest neighbor classifier as well, you require distance measures. So you've learned different types of distance measures. What are the common distance measures that you have learned? Euclidean, Manhattan, Minkowski. And depending on the data type, you might also engage with Hamming distance as well. So we will investigate those. Now, any questions before we start? Students, any questions? Okay, so you guys are all ready. Now, if you recall data, when we talk about data or data, say that data is broken down into, you already know this, into what? We break data into 2 components. What are the 2 components? And actually further, but that's fine. What are the 2 components that we are breaking data into? Students, what are they? One is known as training data. I'm not talking about data types. We're talking about data generally. When we want to train a model, we have training data. So you're looking at training data. And let's say it's approximately 70%. And then also we are breaking it into test data, yes? For your test data, let's say it's 30%. But your test data is further broken into validation data as well. So I'm going to make this 15%, and then I'm going to break that further into validation, and we will assign validation to be 15% as well. Now, this is just an approximation. This is a possibility that this is one way to go about it. Of course, you could have training data 20%, test data, training data 80%, test data 20%, and you might not have validation data at all. But the recommendation is always you should have a validation data. So the validation data is, I'm setting it at 15%. Why am I asking you, or why am I showing you this? Because this is very critical in terms of data mining. Whenever we deal with data in data mining, we tend to categorize data into these categories specifically, and you need to know the reasons behind it. So you need to know, for example, what is test data used for? What is training data used for? What is the purpose of validation data, right? So these are important concepts that you need to revisit. So revisit that. That's the first thing you will be revisiting. Okay. Just bring that up. Now, the next thing is I want you to look into data pre-processing. So everything you have learned in regards to data pre-processing, revisit that. Of course, from transformation, from normalization, from data cleaning, data discretization, and so forth. You need to visit all those strategies, techniques that you have learned about. I would test either theory or I would test either application. So I expect you to know both. Now, so for application, you do have some previous examples from your test papers that shows you where you have a data set that most likely might have some missing values, and you have to know how to go about handling those missing values, right? The hint I'm giving goes through data pre-processing, all the techniques and stages involved in there. Concentrate on normalization. That's important. Students, those of you who have on your mic, please turn it off. Concentrate on normalization. What are the 3 types of normalization that we have learned in this course? What are they? Tell me. Have you studied or not? Min max, good. What else? Z-score, what else? And your decimal. Right, and your decimal scaling. So you need to know all of those 3. Okay. So focus on normalization. Of course, every strategy you learn, you need to know what is it, what is the advantages of using it, and how do I use it for data pre-processing. This was all covered in your lectures, so you need to go back and focus on that. That's important for you as well. The next thing you will focus on, this is your second hint. So the first hint is data pre-processing. The first hint is look at data generally and how data is categorized into training, test, and validation. Then I want you to go into data pre-processing, focus on normalization, take a look at all the 3 types of normalization, understand why do we need to normalize our data, what's the advantages behind normalizing our data, what is the advantages behind discretizing our data, why do I need to transform the data, and so forth. Now, these type of questions might be direct or it might be application, so just be mindful of that. Next is I want you to take a look at data quality. So you have learned about data quality, and we precisely looked at certain measures in regards to data quality. Revisit those as well and see how you can implement it to improve a data set. So assume you are working with your assignment 1, and in assignment 1, you had to, of course, enhance the quality of your data to produce more accurate models. How did you go about enhancing the quality of your data? What measures of quality did you implement and why? So that's the second thing you want to go back and reinvestigate or refocus on during your revision. I have already mentioned data, so that was already mentioned out for you. You want to also look at statistical measures, and that is your 5-point summary. So go through questions that are reflective of that, where you are asked, for example, to draw a box plot, or you are asked to identify outliers. These are some questions, or examples of these questions are reflected in your tutorial questions, in your tutorial questions. So you need to make sure that you revise and understand those concepts carefully as well. And then comes data. So of course you have learned so many types of data, but generally when we spoke about data, we spoke about data being structured, data being unstructured, data being semi-structured, data being a time series, or data being spatial, right? So you want to fall back on that initial notes in regards to data as well. And you should be able to identify what is a structured data, for example, compared to unstructured data. So that's important as well. So go back, revisit those concepts, have a good understanding of it. You need to read through your notes. If you are facing any difficulties, you can, of course, consult your AI to help you understand those concepts further, or you can simply refer to our lecture recordings as well. You will be getting some questions on binning, which is again discretization. So you need to re-understand both the methods of binning that we have learned in this course, of course, by depth and by width. So you want to revisit both those concepts carefully. And the reason you are tested on this concept is because a lot of you did not quite get it right for your short test. So we are retesting you on these concepts, okay? Go through both depth and width, important.
No, the one they sell in Fiji. What they normally sell here in Fiji is ramen.
Students, please turn off your mic.
What did I have? Wouldn't you? Well, I've got plenty here. I had 2 or 3 here.
It shows that all your mics are turned off. So I'm just going to mute all of you. Okay, so all of you are muted. That should solve the problem for you guys. All right, now what we want next. So you will also be tested on discretization. Then, of course, we migrated. These are all part and parcel. Whatever we've spoke about so far is all part and parcel of data pre-processing, data cleaning, and so forth. So that falls within that category. Next, you are looking at classification. So we are diving into classification techniques. And what are some of the classification techniques you have learned? You started with simple rules. So you started with your R0, then you started with R1. Then you migrated into decision trees. Then from there, you went into rule classifiers. And then from there, you went into naive Bayesian classification as well. After naive Bayesian, you worked with KNN classifier as well. Then you migrated to clustering. And in clustering, you investigated, of course, your k-mean clustering, and you looked at agglomerative clustering as well, and divisive clustering as well. But if you see or reflect back on the posting, you will notice that you are not tested on those concepts. So I'm not testing you on k-mean or agglomerative for your MST. So you don't need to worry about that yet. Right, now, I will emphasize if I'm testing any sort of theory, but the application of it, I am not testing. So the first thing I am testing you on is your rules, your classification rules, and of course along with decision trees as well. But just to bring that up, if you go back through your main course shell, And when we looked at decision trees, we looked at classification. No. We had some understanding that if you are not given a decision tree, but you are given a data set in a tabular format, which is structured data, of course, we're talking about the structured data. And in here you are asked, studying the structured data, you were supposed to generate a list of rules. This, of course, falls through your rules classification. So this was the decision trees, which was straightforward and quite easy for you to build rules from decision trees. You are able to do that. You've done that for your short test, which is great. But then we looked at, of course, you'll be tested on entropy since that has popped up. But I'll come back to that. We are looking at extraction rules from decision trees. We are looking at rule-based classification. So that's what we are looking at. So you're looking at rule-based classifiers. And usually this is where you are given a data set. So you're given a data set, but you're not given a decision tree. And based on this data set, you are asked to list the rules. And of course, these rules will retain to the format, which you have your left hand side and your right hand side. We're using if then, such as this. So you want to go back and read on these as well. Now, there's one thing that I need to bring to your attention. Of course, it depends on the nature of the question, but usually when you are asked to construct rule classifiers from a structured data set, that means a tabulated data, the question sometimes states it, sometimes it won't state it. But what you are really looking at, you're looking at PERSM algorithm. That's the algorithm you are looking into. So when you are investigating your PERSM algorithm, if you just simply type this in your AI or on your any web search engine that you are comfortable with, you will understand that for PERSM algorithm, it's all about generating rules with the following steps. So I'm just going to revisit these steps, and it's the same concept that you have learned in your lectures. It's nothing outside of that. So we are looking into version. You are able to see, of course, the content. I'll just make it a bit larger. But this is what we are interested in. So the first thing is you'll select a target class. So in here, you're classifying rules. So you want to look at your output. What is my output? Is it binary? Is it multi-class? And you are focusing on it. Let's assume that you have a given question and your given question has an output of, let's make a statement that your output is, for example, play or not play, right? So you're playing a game or not playing a game depending on few things that you need to take into consideration. So let me bring up a data set for you in here. I'll just bring up a data set for you to examine, and then we'll explain how Persian algorithm works. So let's first select the class. Let's take a look at our data set. So let's assume you have this given data set. I know that the output of the target class is play. Sorry, the output, this should have been output, not the word play, or class, just labeled as class. So it's binary. You either have play or no play in here. So what does it mean when it says select the class? Select the class in here is you want to know what is your target in here. Are you targeting play or are you targeting non-play? That's what we mean by select the class. You cannot select both at a given time. You have to work with one at a given time. So let's assume you go with play. So target class, and let's say for target class, you go with play. Right? Then the next thing you want to do is, of course, these are all my predictors, as you can see in here, but you want to select the attribute value pair. So what does that mean? Based on this example, you're looking at what we call a frequency table. That's what it is, which I have taught you in your lectures. But nevertheless, these are the by literature steps, right? So select the target. So you're looking at play. Okay, then we're looking at, it says number two. Two becomes selecting the attribute value. So what is the attribute value? The attribute value that we are looking into is, for example, if I'm looking at Outlook in here, I can see that Outlook has three possibilities or three values. It has sunny, it has overcast, and it has rainy. Yeah, those are the three possibilities. So it says Outlook has overcast, and it also has rainy, and it also has, we'll get to that in a bit, and it also has sunny. So what does that mean? Now, what that means, if I'm looking at Outlook, to generate a rule, I need to consider for sunny, how many, because I selected play, how many is play? For sunny, how many is non-play, but the focus is not on non-play. So we're only gonna focus on play. For overcast, how many is play? For rainy, how many is play? That's the focus. So what am I doing in here? All I am doing for step 2 is you are creating a frequency table for each predictor. So for predictor outlook, you take a look at what are the possibilities, and depending on that, you are displaying how many of those possibilities have the outcome play from the overall list, of course. So in here, they're saying that if you look at Outlook, for example, Outlook, and we're looking at overcast, predicts play with 100% accuracy. How did they get 100% accuracy? Let's take a look at overcast. Overcast appears in record 3, output is play. Overcast appears in record 7, also output is play. It also appears in 12 and 13 with the output also being play. So that means it's the for me to make a prediction or for me to make a rule, I would simply say if outlook is equal to overcast, your output class will always be play. So in here, you are not calculating the frequency, the probability. You are supposed to calculate it. So it's 4 instances out of 4 of which are all to be play, and that's how you are getting this 100%. So if you want to form the rule, you just simply say if outlook equals for class, then play. Simple as that. So that gives you a rule. Now you will have to repeat this process for all the remaining instances. So for outlook, we also had raining. So you have to examine for rainy, what do we have? So for rainy, now the first thing you want to do in here is really you want to take a look at how many plays do we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 play, but out of this 9 play, we have different values for different predictors. Remember that. But in total, I have 9 and I have 14 records. So 9 is play, and of course 5 is non-play in this case. But I'm not focusing at all on non-play. I am focusing on generating rules. That's what we are after. We want to know from a structured table, how do we go about creating rules? So this is one rule that we have established. The next is rainy. If we look at rainy, what do we have? It says humidity is rainy, remaining 4 instances. Okay, let's take a look at rainy. For rainy, it's also play. For rainy, it's also play. Rainy, it's also play. And rainy, the third rainy is no play. So now I can't make an assumption if rainy is going to give me a play. No, because one of them is no play. So I have to go to the next or to another predictor to help me make a prediction for rainy. So if you look closely in here, they have considered humidity is equal to normal, predicts play with 100% accuracy. This is for humidity. So they're saying if outlook is equal to rainy and humidity is normal, then play. And they've got this, of course, from here. So if we looked at rainy and I looked at temperature, for example, I can see temperature is mild. for the record 4, but that gives me a play. And if I look at record 5, it is rainy, but the temperature is cool. So now these two are not on the same page. They're not both mild or they're not both cool. So I can't work with temperature. So let's cancel temperature. Let's stay within rainy, but let's now go to humidity. Now for humidity, when I want to migrate to humidity, I will have to take a look. This is normal for D5. It's also normal for D6. And we had rainy D10. It's also normal. And we had rainy D14. But humidity in D14, sorry, we had D10 rainy and then it's high. So I cannot take humidity as well. But in here, they're saying that if humidity is normal, precisely play with. This is 2 instances of play. Yes, 2 instances of play would be correct. Actually, 3, not 2. So AI gave 3 instances would be of play. The 3 that I am considering are simply instance 5, 4, 5. Sorry, not 4. Humidity is high, so 5 is the one I consider, and humidity D, which is normal as well. So it is 2, indeed. So then you will construct it in such a way so that comes up, you come up with a rule. Then you will continue on the same path. But let's look at it from a different perspective. Let's assume you have a structured data set and you are given a rule. So instead of you using the data set to help construct rules, what you want to do now is you are given a rule and they want you to validate the rule, whether this rule is considered to be a classified rule or not, using of course the Persian algorithm. Either way, this is theory based. Either way, when you are selecting your attribute pair, my recommendation is you always formulate a frequency table. That means you are calculating the probability of sunny given that it is play, the probability of rainy given its play, the probability of overcast given its play. And then you map it with the probability of hot given its play, mild given its play, cool given its play. And what's the objective behind all that? The objective behind all that is, let's just focus on Outlook. Now, for Outlook, if my target class is only play, and I am calculating the probability of sunny being play, is sunny being play probability higher than sunny being not play in terms of probability? So for sunny, 1, 2, 3, 4, 5, we had 5 records. Okay. So the first 2 I can see is not play, but the remaining would say sunny is also third is not play. And for sunny, D9 is play and D11 is play. So I have 3 not play and 2 play. So 3 is more, of course, 3 out of 5 is more than 2 out of 5 in terms of probability. So then I cannot consider that to be one of the rules that is established by Persian algorithm. The idea behind Persian algorithm is the possibility of occurrence has to be higher in terms of value for each and every predictor. So if I am looking at, in here we used overcast, for example. So if I'm looking at overcast, I only have 1, 2, 3, 4, and all these 4 have an output of play. That means the probability of overcast no play is 0. So of course 1 is higher than 0, so that becomes a rule. Whichever output gives you the higher probability, that becomes the rule for the classification. So again, to simplify what all I am trying to tell you in here, because you might see this word and you will be wondering, what is this? This is nothing but the probabilities, which is reflective of your frequency table. Every time you have a question, calculate your frequency table in order for you to justify the question. So in here, you will see that you are able then to start establishing rules, and you want rules with highest probability. This was a valid rule because it had 100% probability of 1. Now for this rule, if you look at it, we looked at 2 predictors. So you can see that rainy, and of course this is Boolean and humidity, normal, but again, it has an accuracy 2 instances of play. So we are looking at it from here, and you keep continuing. You keep going through the table to eliminate those that cannot be used. Most likely they are weak predictors. So we refer to them as redundant, and we might want to eliminate them from our structured data altogether. But that's how you go about it. Possibilities, you will be asked to generate rules, or you will be given a rule and you will be asked to validate it. So in order to validate the rule or to generate the rule, all you need to do is create your frequency table, calculate your probability. You calculate your probability, whichever one gives you the highest probability will be the established rule. That's what you will or that's what you will be doing. Okay. So always, number one, focus on the target class. Once you have focused on the target class, then you want to calculate the probability of the attribute value. So calculate the probability of sunny being play, probability of sunny overcast being play, probability of rainy being play. Focus only on play. Do not worry about no play. Calculate the probability of hot being play, calculate mild, probability of mild being play, probability of cool being play. Calculate for humidity high being play, calculate probability of normal being play. That's the only two we have. And for wind weak play, strong play, those are the two we have. So that's the next thing you will do. You will end up calculating the probability for each attribute value pair that will help you predict the class play. That's what your interest would be. Then, after you have calculated all these probabilities, what are you going to do with it, of course? Then you're going to select the attribute value pair with the highest probability. So, if sunny is giving me the highest probability for play, sunny becomes in my rule. Overcast might fall behind it. Rainy might fall way behind it or might not even be applicable. So then sunny becomes the highest, for example. In here, of course, for us, overcast is the highest. Same with temperature, hot, mild, cool, calculate the probability. Which one is the highest? So assuming that maybe mild is the highest. I'm not calculating anything, but you need to calculate it. Same with humidity. Same with wind, okay? Then we will find out which one of those have the highest probabilities. Now, of course, if you are, this is how you establish your rules. So highest probability becomes a rule. Highest probability becomes a rule. Sometimes you will have to make combination. Why will I have to make combination like I did in here? Because if I looked at rainy only, I can see that I have 2 rainy play and then I have 2 rainy that are not play. The focus on rainy is only on play. I don't have to worry about not play because that's my target class. My target class says play. So only focus on play. So for play, if I look at temperature, I had this is not equal in value. This is mild cool, so I cannot work with temperature. But if I looked at humidity, then I can see that humidity also is high and normal, which is also not the same, by the way. Wind is weak. So your rule would say if rainy and wind equals weak, then you can have play. But consider also weak in this aspect. I have weak play as well, weak play in here as well, weak play. So weak is generating for me an output of play. You will focus on probabilities that are affiliated with the target class. So first focus on play, then focus on not play. In simple words, all you have to do is just create frequency tables for the outcome class play and not play, and the one that gives you the highest probability will become your established rule. If the question has given you a rule and it's asking you to confirm whether it is considered to be a classified rule using Persian algorithm, then use that rule to your advantage. Take a look at that rule. What do I mean by that? For example, take a look. It says in here if outlook is equal to overcast. So you want to go to overcast, calculate the probability of overcast when the output is play. If the rule was given as if outlook equals rainy and humidity is normal, then play, calculate the probability of rainy for the output play, calculate the probability of humidity for the output play. But you want to measure the probability of outlook rainy probability against sunny and overcast, and you also want to measure humidity, normal against high. So those are the two things you need to measure. So you'll be calculating the probability for normal when it's play. You'll also be calculating the probability of high when it's play. Which one is of a higher probability? If normal has a higher probability than high, then it's considered to be a valid rule. Alongside, if rainy had a higher probability, of course, than overcast compared to sunny, then this is of course considered to be a valid rule. And again, it gives me 100% accuracy because you have combined both. So you'll see that the probabilities for these two given will always be play. If you fall back on overcast, and you look at humidity, this was high. If you look at humidity, this was normal. If you look at humidity, this was high and this was normal. So I had two high, two normal, but which ones of them were play? So if I look at humidity for for overcast, normal, it was a play, and humidity for overcast, this is high, but it was play. Overcast, this is normal, but it's a play. And the third one is D, which is also normal. So you have 3 normal and 1 high in that case. So normal has a higher probability, then it's 3 out of 4 in that scenario. So that's how it's generating the rules for you. Is that clear? So you want to go back and take a look at your notes, which is reflective, of course, of extracting rules. This says extracting rules from decision trees, but the whole idea of rule classification is you are going to extract rules from structured data. So you are usually given the following. You are given a table, and based on this table, you will be asked to create rules. So here, something similar to this example. Characteristics of mutually exclusive rules. This is some characteristics of these rules and the applications of it as well. So as you can see in here, you just have structured data. You will not be given at all anything in regards to a decision tree. So you will not be given a tree in this. Now, the second hint or the third hint you want to look at is coverage and accuracy. So look at the formula for coverage. What is coverage? What is accuracy? You have examples in here as well for coverage and accuracy. We looked at it in our lecture slides as well. Coverage of the rules. So reflect back on that, learn how to calculate your coverage and how to calculate your accuracy for your rule as well. You can see in what we are talking about in regards to our Persian, they always look at the accuracy of the rule. You want both coverage and accuracy. And it tells you it's covering 4 instances. That's the coverage. It's covering 2 instances. That's my coverage in there. Okay, so those are the other concepts that you will be tested on. So you're definitely tested on structured data, where you are asked to generate classified rules, or using Persian algorithm. That's your classification. Take a look at coverage and accuracy for your classification rules as well, using the format if then. That's the format you'll be working with as well. Next, I will be testing you on information gain. In order for you to calculate information gain, you should be able to calculate entropy. So if you remember, the first thing we do is we calculate the entropy of the class output, right? So that's the first thing we do. We'll take a look at our data set, and based on our data set, we calculate the entropy of the parent. That's how I have taught you. Parent is the outcome, which is the class. Then after you have calculated the entropy of the parent, then the next thing is you want to calculate the entropy of the children, or yet we say weighted entropy of the children, right? So the weighted entropy of the children are the predictors. So then you will, based on the frequency table that you have created, how many instances, depending on the output class, then you will calculate the entropy for it as well. I hope you all know how to feed in your entropy because it's base 2, log base 2, right? So we all know how to do that. Yes? It's just the log of the number divided by log 2. So if I say log x to the base 2 would be equal to log x divided by log 2. That's how you'll do it on your calculator for simplicity. Right, you need to know how to calculate those values, so you'll be tested on that as well. And once you have calculated the entropy for the predictors, or I refer to it as children, and I divided that step, then step 3 is you will be calculating the weighted average entropy. After you've calculated the weighted average entropy, then you will be able to calculate the information gain. Because information gain equals to the parent entropy minus the weighted child or children entropy, right? So you will then do that. So please go back through your notes again, take a look at your tutorial questions, and also consult AI. That means feed to it questions based on the exam papers that I have put up for you on Moodle, or previous past exam papers. Investigate those as well. It will be to your advantage. Feed it and ask AI to generate new set of questions where you need to practice those as well. Entropy, information gain will be tested. The next thing I'm testing you on is I'm testing you on the classifier and KNN. So you need to re-examine the notes for KNN as well. Now, of course, when you are working with KNN, you will have to implement distance measures. The distance measure that you will implement, of course, depends on the data set. If none is mentioned, you would go for Euclidean by default, but if there is mentioned, then you have to focus on what's mentioned. Now, to make things more simplified for you, for this given test, I am testing you on Hamming distance. So go back, take a look at your notes reflective of Hamming distance and what type of data does it apply to as well, okay? So you'll be tested on that. You will have a theory question based on a Bayesian classification. So I'm not testing the application of it, but I'm testing the theory part of it. I've left the application for your final exam paper. And then I'll be asking you a final question. I think that's your final question, yeah. The final question in your MST paper will be a multidimensional confusion matrix. Do you all understand how to work with confusion matrix? I have given you a simplified set of notes on Moodle, so you will go through it as well. Go through your tutorial questions as well, and through any questions you can encounter from the short test or the MST papers that I have posted for you on Moodle. That should also help you a lot in your coming test. Any questions? Anything you're facing difficulties with you would want me to discuss? And I think moving forward, I'll try and fit this into my schedule. It might not be possible, but I'll fit it into my online schedule. We'll start, since we have only 6 weeks, and we've already almost done with the first week of the 6 weeks. We will start online revisions to help you prepare for your final exam, and this is especially for those of you who are struggling. And I'll start doing questions in there, focusing on the concepts we have learned so far. Right, this is your time to ask questions. You've got 15 minutes, so go ahead. Bombard me with your questions. Let's see. Students, you are able to utilize, of course, your chat. I just muted you, but I did not stop your chat. I will not tell you what dimension the matrix is. It's just a multidimensional matrix. So go back, like I said, based on the confusion matrix revision that took place. If you're able to do 3 by 3, you will be able to do 8 by 8, 9 by 9. Any other multidimensional will not be difficult for you. It might take more time in terms of calculation, but it's the same exact concept. No, actually, the person in charge did email me on Tuesday and it was confirmed. So you want to contact, I think it's Dorsey or Dorothy. Contact her. She already has the paper and she has already the venue is created for you as well. Let me just double check in my email, but I did receive a confirmation from her yesterday. Dorsey. Yeah, I have her confirmation. So just follow up with her, please. But this was her confirmation. So you can follow up with her. How many rules you would have from Persian algorithm? It depends on the probabilities. So what are all the highest probabilities in your data set? And again, the focus is on what's your target class. So the question might ask you generate rules based, like we just saw a data set, based on the class play. So you'll forget about not play. You don't have to worry about it. So you'll focus on all the predictors probabilities for play. And the probabilities that accumulate to the largest value will be used in generating those rules for you. So it's not something I can state. It depends on the probability value in that case, okay? Theory aspect is tested. The theory based on a theory for naive Bayesian classifier is tested. However, the application of it is tested in your final exam. How about I just give you out the question, bro? I don't want to I can't tell you what type of theory. I'm just giving you a hint that reinvestigate everything about naive Bayesian. What is naive Bayesian? How does it work? Etc. Take a look at that. What are some? What's the other question? Will a theory question be a normalization or practical? You will most likely might have a combination of both. Or one kind of, I think combination of both. So examine both. How do you know that you started hiring pairing? Okay. So from the data set, when you look at the data set, you want usually sometimes, I'll be very honest with you, sometimes the data set gives it away to you. We had an example of this in our lecture, and I even had a student walk up to me. The reason is, so study your data carefully. So if you're looking at forecast in here, it was all play, so we didn't have to worry about all the other predictors. We made the rule for that. That's great. Then we have to look at the probability of sunny and rainy. Is rainy higher than sunny? And seems like it is, and that's why they went for, I believe, sorry, outlook is overcast because the outlook is rainy. So they went for rainy because rainy's probability most probably was higher than the probability of sunny. So that's why we went for rainy next, okay? So again, even if you didn't calculate the probability, you will see that there's rainy, we have 4 in here, and out of the 4 there's 2 play. I can see that, and the focus is only on play. I don't have to worry about the others, which is rainy not play, and the other rainy that says not play as well. So I can see that this 2 rainy that I'm focusing on generates a play for me as well. If you looked at overcast, it also generates a play for us as well, right? So just look at the highest probabilities. In here, for temperature, why did they drop it, or why did they go directly to humidity? This is not a worked example by me. Actually, I didn't do it. Usually I do all my examples myself. This is just something that I have pulled out from the search engine. But you will just understand the idea behind is for you to understand, before I can conclude any rule, I need to calculate the probability. So I have to calculate the probability of hot for play, probability of mild for play, and probability of cool for play. Out of these three possible values, which one gives you the highest probability? Repeat it for humidity, repeat it for wind, and repeat it for, for play. Play is the outcome. So that's how you will look at it. So eventually your output becomes, or your rule is established based on the highest probabilities. What does that mean? That means you will select the attribute value pair. We call it attribute value pair, which is, what does attribute value pair means in here? Conditional probability I'm looking at, right? So let me also clarify that for you. Why am I calling it value paired? Because I'm looking at sunny, play. So it's a value pair. What's the probability of sunny when the output is play? What's the probability of rainy when the output is play? What's the probability of hot when the output is play? What's the probability of normal when the output is play? And so forth. So we refer to it as a paired probability because you're always measuring that probability against the outcome class. So the third step, after you have calculated all those probabilities, the third step is you want to select the attribute value pair with the highest probability. The highest probability will generate the rule for you. Okay, so that's how you work with it. Yes, because it had, or you have to calculate it, but yeah, presumably because it had the highest probability. And here, this is just an example to show you that this is how we go about it. So first you want to select, it says here, number one, select the target class, select it to be play. Did they select it to be play? Yes, they selected it to be play as well. Then you want to select the attribute value pair. So what's the attribute value pair? You want to look at outlook when it's predicted overcast for play. So probability of overcast given play. Probability of humidity given play. Probability of sunny, sorry, it's overcast, sunny, and rainy. So what are those probabilities? That's what you are looking at. That's what you are calculating in here. Same applies to hot and the other attributes. Okay. Now, what did you mention about this train and validation data? These are different. When you have a data, you take your data set and you divide it into categories. Oh, I'm in a class. Wait, will you be okay? Once again, I'll be in a second. Just hold on, please. Okay, sorry about that. So the idea behind it is you need to understand that our data is classified into training, into test, and into validation. You need to ask yourself why. Why do I do this to my data set? What is the purpose behind it? Can I have all my data just to be, for example, training data? And if so, what impact will that have on my model? Can I only have it all to be test data? And if so, what impact will that have on my model? So the question is, every time we work with data, we actually separate it into these categories. Now, this doesn't mean you're going to take a data in your assignment 2 and make it 17 and 15, 15. No, this is just a representation of a possibility. A lot of people have the training data to be 80 and the test data to be 20. And they stop there. A lot of people, they just go for training and test. But I have taught you it's not only training and test, you always want to also validate the data. Validation data is extracted from the test data. So you can see that your test data in here is 30%, but I have divided that equally, not necessarily equally. A lot of people might have said test data is 20 and let's validate for it to be 10%, for example. So you need to understand what is the purposes of these data, or why do we categorize the data into training, test, and validation, right? So that's the question. that is related to that aspect. It falls under your assignment. This is something you've done for your assignment. So the focus in here is you want to reflect back on what you've done for your assignment. Of course, it all boils down to improving the quality of your data and model accuracy, but you want to dive more in depth into what was the issues that you had addressed when you divided your data as such. If you had not divided your data as such, what are some of the issues that arise? Okay, so it's a critical question, but applicable. Let me reiterate by simply saying that you have to focus on everything in regards to data pre-processing. So revisit your data pre-processing, the theory aspect behind it, all the strategies that you have learned, along all the application aspect of it as well. You will be tested on that category in your MST. For a worked example, you could do this yourself. You are a third year student, by now independent learning. You simply ask AI to generate a question for you on Persian. Yet, you could use your notes directly from here without the decision tree and ask it. Of course, it contains different types of data you can see in here. So you have categorical data, and then you have continuous data as well, and ask it to generate rules for you as well using Persian model. Feed exactly the structured data if you want and see what's the output. And you can ask it to explain it for you as well. This is the indirect method. What are some other questions? We've got 3 minutes to go. Okay, since you have no other questions, then I'd like to wish you the very best for your MST tomorrow. Study hard and aim for a good mark, especially if you have done poorly in your short test. Try your best to pull up your marks for in MST. The instructor in there has also confirmed. I think it was 16. So you also want to follow up with her as well. Follow up with your campus. They've already confirmed my email, so definitely they'll host you. Right, wish you guys all the best. We'll end the session here.